Hey. Hello, and welcome to my presentation. What eyes don't see, the ears will not hear. Uh, I will be talking about diagrams and why we should use them, and maybe why we shouldn't write so much, and that maybe we should be presenting more visual stuff. But before we do that, let me introduce myself. My name is Józef Piecyk. I'm a software engineer at Shipsetek Polska in Gdansk. I'm also a bootcamp trainer, and I know an awesome waffle recipe. Please do not mistake them for waffles. These are two different kinds of things. So the presentation plan is the following. First, I will be talking about why we should consider using diagrams, what problems they are aiming to solve. Then we'll go into a short list of why we should care, why we should consider using them, but only from personal perspective. I will not be talking like why shareholders will benefit from it. It's about how you can use them to help your career. When we should consider using them, spoiler, it's always, I think. And then I will go into showing some of the tools and also some examples of diagrams that help me in hope that it will remind you of a situation that you were in that could have been easier if you went with diagrams, but you didn't maybe. And now, if you face the same situation once again, maybe you will consider showing it more visually. And also, I will call everything that is visual. So if you will see and you'll be like, technically, it's not a diagram, but it's a I don't care. Sorry, it's uh, it's it's the tool that is used for something, and I will be treating it like this. So first, why? And I will be talking also for the context. I will be talking it in the context of software engineering. So as a developer, why we should care. So first, what are the some of the problems that we are facing when developing software and software systems? Uh, Software systems are usually not simple. They are complex, they are complicated, there are many paths to take, there are many things that have to happen if you want to start somewhere and end up where you want to be. Also, there may be some of the things that you are not aware at the first glance that are happening or are required that you should know about if you want to be successful with your current task or implementing a feature or maintenance. The other thing is that rarely the issue or the thing you are trying to do in a system is isolated. Many things are talking with each other, and many things are dependent on each other to finish what you are trying to do. And why, if you've been working on it for a few years, if you want to add someone new to the team or introduce the problem to someone that is not as capable as you, then it may be an issue. Another thing that apart from many things working together, you also need to know how they are working in together, when, why, and how they are interacting with each other. The other problem, which we really like in software development, is naming stuff. And sometimes things are named and then are forced onto their function. But sometimes we can even be brave enough and crazy enough to first look at what the thing is actually doing, and then we will actually know how we should name them. And diagrams and any visual representation really can help you with that. And then there's a problem of documentation, which usually isn't the problem with documentation, is the problem with documentation simply not being there, right? So if you are using any visual form or diagrams, they can serve as documentation. They can be used as a point of reference, and also they can be used to basically load up the conversation. But why should you care, right? It sounds fine, but what's in it for me? So first thing, I think the biggest one is that it will make your life a little bit easier. it will make you maybe a little bit less tired or less stressed or less frustrated with starting a new thing over and over again. If you'll just write it down and as a diagram, then it will be easier to explain to other people and to go back to the conversation. It goes back to the limiting repetition, right? If you're starting from scratch each time, you will have a bad time. If you are starting from something that you can refer to and point to, it will make it way easier. Also, diagrams can be used for debugging, and it's not like there are two types of people, but some people are writing their thoughts on diagrams, but also there are people who are by drawing they are thinking, right? So they can discover their own thoughts, and this can be really helpful with debugging because you can say what your assumptions are and then verify if they are actually met. Also, going back to conversation is way easier if you don't have to go back to the whole narrative that we were doing this and this and this and this connects to that and that and that and we've been blah 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 blah. You can just point to the red arrow on the diagram and it will be so much easier. And also, it's not obvious, but presenting kind of makes you seem like an expert. I have a presentation here. It's not guaranteed that I have something really worthwhile talking about, but since I'm presenting, it seems like it, right? So if you want to point to the conversation you're in into a place you want to be in, you can just do it by drawing and pointing like here is the thing that we want to talk about now. So now how diagrams help us? Few thoughts to kind of anchor us in the direction we are going in. So first, diagrams make it really easy to display the complexity and also the relationships between stuff, right? The relationships and the groupings. If I were to describe this thing that you're seeing here just by words, it will be quite complex, right? We have a blue module that has three things, and all those three things are talking with a thing one of a red module, which is connected to a database and also relies on thing two that is connecting to the third party API, right? But if we were to see this diagram, we can see that if we want to do something with thing one, we have to be aware of three blue things and thing two that may also be affected, right? It doesn't take much time, but it's easy to us like here, this is the focus, right? The thing one. You see how it relates to each other, right? Same if we said, well, oh, this is thing one. It doesn't really, it's more isolated than the red thing one because it just connects to or relies on the red thing. The other thing that we can do is also the process discovery, especially if we are using techniques like event storming. So say we have some events that are happening in our system that we write down. So we have some event here and here and here and here, right? And then we see that there's have something in common, right? So we can put them into just visually, right? We don't have to even code them, but we can put them into some modules, right? So this is our module or subdomain or whatever. But we can also say like this is something to watch out for, right? Like this is a hotspot or so there are some side effects. But now the two great things are that we can talk about some events in isolation. So we have this last module, and we can talk about those two events. These are the ones that we care about, right? Because this is a meeting with marketing, and they can only care about those two because there's only um, these are the two that they actually care about. Or we can even go another way, right? Instead of going from left to right, we can go from right to left and say, okay, this is some event that happens at the end, and this is the one before. Is there anything missing in between, right? Or should be something that can also happen instead? If we are doing it visually, we can see we can go through things slower, but we can also um, be more aware of the gaps, right? Because it's not like everything looks the same here. And now meanings and names, or actually discovering them. This one I will show immediately on example because it's quite vivid in my memory. So we had a process in our system that was that the banker was requesting indication, then the valuer provided indicative price, and then valuation was chosen. And in our system, we had an indication and valuation. There was an actual indication API. But it turned out indication and valuation are basically the same thing. And the actual thing underneath is the case, the loan case, right? So we've been confused over and over between the changes like the indication between the indication and valuation, and they turned out to be the same thing because a system was developed, more things were kind of added, but not really, and we've been using the old words to describe the new things. But it was clear here that we saw that something wasn't quite right, right? We wouldn't see it in the doc, but we saw it here. So now, what are the tools I'm gonna suggest you trying out? The important thing here is that I chosen the tools that are really easy to use, right? They are basically you can sit and start using them. They don't require a course, then don't require anything else. So, and this is the it doesn't matter how good the tool is until if you are not using it. And this is the issue that I have with some of the tools, that are some complex that it's difficult to make decision how you're actually trying to use them. So the four tools are the Excalibur, which is the default one I'm using. Then we have Miro, which I suggest using with, especially with business and for event storming. We have Structurizer for C4 architecture, and we have Mermaid that is usually used for DevDocs. And why your tool isn't here? Because maybe I don't like it, maybe I don't use it, maybe I don't know about it, and maybe it's even better, but I haven't had a opportunity to learn it, right? So now we'll go one by one through each tool with a short demo. So the first one is Excalibur. The nice thing about Excalibur is that gives it kind of a nice hand-drawn feeling to it. So you can write down arrows, you can do like the triangles, squares, and all that stuff, and write something down. And the nice thing about it is that it's really easy to use, right? So let me maybe zoom in a bit, right? So what you can just do is do any like rectangle, something A, then you draw a line. You want it to be more sloppy because this is how you're actually writing it down. And the nice thing here is that you can actually share it, right? So you can do the live collaboration, add other people so you can do it together, and you can easily scroll up, whoop, up and down so you can go back to the stuff that you've been uh, writing down before, right? So if you are talking about someone with someone and you get lost, then you can just start drawing, and it's like, okay, this connects to this, and here we go. And then you can see if something's more complex than you expect it to be. You can say, what about this one, right? And you can kind of have easier time guiding the conversation, going here and back, and then you can just screenshot it and save it to someone and send it to someone. The next one is Miro. And the Miro, I think this really liked in between project managers and Scrum masters and people like that. And the way I especially like using it is to use it for event storming. So the event storming is a technique where you are attempting to describe the system by using events and some other pieces, right? So you are talking about the thing that actually happen in your system that are changing its state, right? So the example that I'm showing here is when we've been working on the automation for task management system. And we started to describe what actually happens there, right? We create automation, we edit it, we toggle it. The task has been added, so we have to do something about it. The time has passed, so we should do something. We should move a task, add a member, and stuff like that. And once we were done with that, it was easy for us to see like how should we group or how should we define our modules in the system, which allowed us also to see which are the things that we will have issue with, right? So so this is Miro. You can also like zoom in, zoom out, fancy things, arrows and stuff. But I think where Miro really shines is when you want to collaborate with people who are not developers, right? Because the interface is nice, it's really easy to use, and it's generally well regarded in the business with the business people, right? So the next one is Structurizer, but before we go into Structurizer, I think we should talk a little bit about the C4 module for visualizing software. So the idea here is that depending on what you actually need, you require some kind of details, right? So the example they are showing here is with the maps. Zoom in, maybe. Bum, bum. Doesn't want me to zoom in. Yeah, doesn't quite respond. Doesn't matter. So the idea is that depending on the decisions you are attempting to do, you will need a different kind of details, right? So with example of the maps, if you want to talk about the relationships between different countries, you generally need to know what are their borders, how they are neighboring each other, how far away they are from each other, and so on. But then, if you want to talk about how things work in the country, you would be more concerned about where the cities are located, how they are connected, how they are grouped with each other, right? And then if you are actually attempting to maybe you want to move to a city, you would want to know more details about the city alone, right? How where are the shops, where are the kindergartens, how well communicated it is, what is the public transit and stuff like that. But when you actually want to go somewhere and you want to ride there, you care about the things on the road, right? With this street, if I turn right, I'm gonna be in this street, right? So depending on the decisions you are trying to make or the people you want to have a conversation with, you will have a different level of details that you want to use. And the same goes for our system. So in the system context, if you want to see what are the systems involved and which systems are talking with other systems and what actors are using the systems, then you want to be quite broad, right? But then, if you want to talk more about the application and who's using it and how the applications communicate with each other, then you need a different level of details. And then if you want to understand how the given application or the service is working, you might want to have additional more details, right? Maybe about the controllers, maybe about about the components of or the modules of a system, right? So C4 allows us to do that, right? So we define our our elements of the system and then we visualize it on the level that we require. And Structurizer allows us to do just that, right? Here I created a sample model, and as you will see on the left, you see that there's a model on the top side, and then we also have views, right? So first, we define what is our system, what are its pieces, and then we visualize it, right? So the pieces that we have available here is person, software system, So the software system is, for example, here is the GitHub, Stripe, or our app, right? So this is the externally accessible thing that we can do something with, right? And then we have containers, which, well, there are different interpretations of it, but the way I see it, the container is something that you can deploy, right? So your backend application, frontend application, your your database, Redis, whatever, right? And then we have components. Components, however you define it. So you have in the front end, maybe you have pages. In the back end, maybe you have modules. Or even you can go deeper and you want to say that the different components is the controller, the repository, and the service, right? And when you have those described, uh, you will say how they relate to each other or what they are trying to do with each other, right? So the users goes to a product page to display the product list. And the product page, which is a component of a front end, is fetching product list and the listing modules and gets things from database and blah blah blah, right? It can be quite big, so maybe it is not worth doing it for your entire system, but to inform the decision that you are attempting to make, right? Because it can get quite verbose, big, tedious, and stuff like that. And then you define your views, right? So we have the view of a system, of a container, and a component. And here we get into the actual nice part, is about how we can present our system, right? So in the system context, we see the user that is interacting with our application and it authenticates with the GitHub and it processes payments with Stripe. But if we go a little bit detail and focus on our sample application and the component within it, then we can see that the user is actually interacting with our front end that interacts with our product API that gets things from the database and publishes events on the Redis, right? And it uses Reddit as a publisher subscriber, right? And it's the actual product API that authenticates with GitHub and it processes payments with Stripe. But if we want to introduce a new developer to our team, maybe it's worth going into more details, right? So we know that the front end is doing some stuff, but it creates order in the order module, it logs in with the authorization module, which authorization module in turn goes to the GitHub, right? Because it authenticates user with GitHub. We also have a listing module that connects to the database, and the order module actually speaks with two modules. So we have the API email module and the payment module, right? And this is the way how we can showcase and display our architecture on the in the how in the amount of details that feel appropriate for us. And then the last one, Mermaid. A Mermaid is a tool that is using the best language ever, which is Markdown, and it allows us to make visual representations of any kind. And the best thing about it, apart from being able to be read even if you don't render it, is that you can easily share and embed the diagrams that you're actually making. So if you would embed this graph into a GitHub pull request or issue, it would render, right? So if you feel that something is really complex and you had to explain it to second person, maybe committing your diagram by the place it's used makes sense, right? So example is here with the mermaid that as you can see on the zooming is weird here. On the right, you can see that I have a sequence diagram where the client connects to GQL, does something, then GQL connects to Melvis, Melvis to GQL. Stuff happens, right? That you can read, but it creates us a nice diagram, which is a sequence diagram, right? Where you can see who is talking with whom and why. And since it's code based, and you will see like, oh, the redirect, oh, the redirect after payment happens too quick. Well, you can actually move it around, right? Because it's in the code, so it doesn't. It can be easily updated, right? But also the nice thing about the Mermaid is it will automatically generate the URL for you. So if you want to share it with someone who knows more about the issue, you see I have the private tab. I copy it in and I have it ready, right? So if you want to share it with someone and have them take a look and update it, well, you can easily do just that. So those are the 4 tools. So again, Excalidraw, always open. If you're thinking, if you're talking with someone, you can just draw around. Miro, if somebody from the business has to be involved and they like the nice tools. Structurizer, if you're talking about the C4 and architecture. And Mermaid, if you are doing developer docs. And also since the C4 the architecture seems complex, the best use case for it is if you need the depth, right? You want to talk about this level and this level and this level, and you want to hide details away. Because this is usually the place where the mirror is not enough, that you cannot hide away the stuff that you don't need at the moment. This is where the structurizer is really, really useful. So now the real life examples, and this is the section in which I hope I will be talking about some issues that I had that would be way more difficult to deal with if I didn't write diagrams there. So first off is the issue of authorization and application we've been working on. So so it was the worst type of it works for me because it was working in my Insomnia or Postman, but it wasn't working in my application. So what was happening is that I was logging in with my user, Józef Piecyk at Shipstead. I was trying to do some operation, and then we have this. The way the authorization works in our system is that the GraphQL layer exchanges token with some backend, and then makes a request. Um, as I thought was in the name of the user, right? I impersonate Józef Piecyk and make requests on their behalf. But it turns out it doesn't work that way because instead of using tokens underneath the hood, we are using the actual user that is making the request, right? So we are exchanging a token. And now when I'm making a second request, I'm no longer Józef Piecyk, I'm MA2, right? And the MA2 is not a super admin. They cannot do this operation. So now I had a way to verify if it works. I could easily test it if with the token for MA2 I can do the operation. I could. So now what all I had to do is just screenshot this and send over to people from the service. And they immediately knew what was wrong, right? But I knew which steps were working, which steps were not, and which were the actual issue, right? You can see with the color that the yellow thing is bad. So please take a look at the yellow thing. The other example is from the conversation we had about the structure of our code. So the team I was working on at the moment was insisting on keeping everything at the root level. So all the type loops it lived in the folder of types, all the utilities or library functions. I don't know what was the difference there, but the lib was the lib. The utils were living in utils. There was even an enums folder, and I was waiting for the arrays and objects folder to come in as well. So what I suggested is that since we are using authorization types only in authorization, and the authorization libs only in authorization, and utilities for authorization only in authorization, maybe instead of keeping everything at the top level, we should be keeping it at the module, right? So also to drive the point better, I showed how it's different, right? And the difference seems quite subtle, but if you write the arrows down, they create quite a visual mess. You see that everything's convoluted, right? But here, everything is nice and tidy. It is where it is. It's not used outside, so it doesn't have to leak outside. If something had to be shared, it should be shared. But the default should be to keep it lower than higher, right? Another example, it's if you actually want to make this wafers, you can just go for this presentation, pour everything up, uh, like the half cup of sugar, half cup of butter, it's a half a butter. And then once everything's about it, pull in the powdered milk and spread it, and you're good, right? So the issue that we faced when developing a system in micro frontends architecture was that there was little to no coordination, right? So we had the issue was both on design end and on the web end. So our designers were creating the views in separate. So each view, for example, if they were using a table looked a little bit different, right? And then since each team was also implementing their own table, each table looked a little bit different. So what we came up with was to create a common components library where we would create a table, as you can see at the bottom, that would encapsulate all the sorting and pagination and other functionalities, the testing, and also it would keep our design the same, right? But also, it's not only the issue of our web developers, but also designers not keeping up with our way of working. Right. So we had a meeting where I was making a case for it. So the way we've been working previously was that each Figma design at the top had its own design for each page. Right. You can see three red rectangles there. And then you also see for blue ones that are um, the replication of it, right? So what we were suggesting is to create a common designs atoms, right? As you can see, the one thing instead of three different things, implement it once, and then reuse it using npm. So if non-technical people are not able to understand what the micro frontends are, the implementations of a table and stuff like that, because they don't have to. But I think what they can actually say is that instead of having three different pieces, we have one that is shared, right? And one is less than three. And since this is the effort, it's better and cheaper and nicer and faster and all that stuff. Um, this is the example of automation that I mentioned in the when talking about Miro. But one thing that I would like to mention here is that by doing this exercise before implementing, we knew which parts are going to be problematic, which parts are going to be done at the end, because we had no decisions on it yet. But also it gave us it gave us more vocabulary to talk about the automation. So when we started working on the automation, the things that our customer was saying about was like the automation of type time based was doing something, 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 right? But when we took a look at the feature and what it does, we noticed that there are three distinct parts to it, right? The automation management, the trigger handling, and the effect application. And what we noticed is that the automation actually is a thing that makes sure that the right trigger goes to application of effect, but also that the only thing that has type is a trigger, right? So there's no automation of type base. There are only time-based triggers. So if we want to add more triggers, we can do that. We can apply automations if things happen, but it doesn't really matter what things happen because the triggers are handling that, right? They are just triggering. And it gave us more confidence in speak with our with our customer, but also it gave them more confidence because they saw that we are actively discovering what we are trying to do. The other example was a situation where we had a really bad time in our project, and we decided that since we are talking and whining a lot, maybe we should just write it down and see what happens then. And when we were starting to list all the issues that we had in the project, we noticed that there are some patterns here, and most of these patterns are actually workable. So we can fix them, and instead of just talking about them, we can work on them. And we also saw some common issues that we had, and we decided to share it with our client. And the result of that was that we created a lot of tasks, and even when the things were not finished yet, it was easier for us to bear with it because we knew that it's gonna be taken care of, right? We had a plan, we've been heard, and we also were kind of hopeful that the things will get better and better, right? It doesn't have to be perfect, but if we're going in the right way, or if we are deciding that the issue that we're worrying about is not actual issue, that was the thing with, for example, translations at the top right. We were stressed that we had no translations, but it turned out there's no translations in the plan, right? So this was maybe not straightforward way of doing that, but but uh, this works, right? The other investigation that we did into our like co-bottleneck was that our the fetching of our lists was really wrong. So what we decided to do is to list all the operations that are taking place in the application, right? So we just went and what was talking to what and why. And what was quite surprising to us was that in to gather this list, we had to make the 8 different DB requests. We had to make 3 different HTTP requests for the same data, as it turned out to be. And also, it was easier for us to to make a case that this is an issue that had to be solved, because it's easier to say that you have some issues to solve, and you see there are a lot of arrows, so that's bad, and bad. A lot of arrows are bad, and we should solve them. Another example was when I joined a new project, and I was quite overwhelmed by it. So I was not sure whether I should be overwhelmed or not, so I decided to write down everything that I could know about what connects to what and how many services there are and why they are talking with each other. And I ended up with this, right? So what I ended up with made me feel that it's a right for me to be overwhelmed, and I should give myself time to get to understand it. Because as you can see, there's a lot of things, so I also should take some time to get acquainted with each other. Another example is a situation where we've been authorizing with GitHub for our feature, because were making a GitHub integration, and there are 2 ways of authorizing with GitHub: the auth tokens and GitHub app tokens, or however they are called. And the issue with GitHub OAuth tokens is that they can have only one callback URL, which is an issue when you have 4 different environments and 4 different URLs that you need your users to go back to. So what we decided to do is to encode the information about where you should go to in GitHub code, because you can do something like that. And then our only GitHub callback URL was the GitHub authorization proxy, which was just basically a router to the proper environment. And now we had to explain to our DevOps why we didn't want to deploy it everywhere and why it should be accessible outside. Well, now it's visible. Why? Because this is our environment, this is GitHub system, and it has to connect to something outside, which has to be in only one that we can do something about. Another example was of payment flow that was not quite clear for me how it works, and I received this huge wall of text on how it's working. So I went through and asked questions, right? So the client goes with mutation initiate payment, and then GraphQL goes to this, and this provides the payment URL, and now user does this, and now the user connects to the payment processor connects to this and redirects them. And also I have to know something and something gets triggered and stuff like that. And now we could have an honest conversation about what we're missing or what is not clear or where the issues can be and what types of errors we should be prepared for. And also, since I was doing it in Mermaid, I actually embedded it in our GitHub pull request. So I was like, guys, this is the feature I'm working on. And this is how it actually works, right? So all the GQL stuff I'm doing is that I'm doing it, right? So the conclusion, diagrams could just save a lot of pain. Just use them. If you don't know which one to use, just use Excalibur. If you slept for the entire presentation and you're like, oh, I need one conclusion from it, just open up Excalibur, and when you have a next boring meeting, start drawing a little bit there. But if you are also interested in some of the others, one thing that I didn't mention with Mermaid is that it actually has some samples here. So if you want to check how to make a sequence diagram or a flow diagram or something with state or some other weird stuff, you can just check it, right? And see what works for you and what does not, right? Um, cool. And that's the end of the presentation. So have a nice day. But also I saw that there are two questions. So maybe let me answer them. Have you used Structurizer on-prem, cloud, free versus paid? Do you have any tips on automating this? I have not used the paid version of the Structurizer, so I'm unable to answer it properly. And about the automating creation of graphs, I think before you start to automate, I would suggest to ask yourself the question of what you're actually trying to achieve from your graphs, right? Because we always like to have graphs. We also like to have them hanging around and have them be automatically updated. But the most important thing about any visual form is to know what decisions or what conclusions do you want to get from it. Uh, if you want to automate it, I don't know of any ready tools, especially in Python. I know that you can do Mermaid graphs in Next using Next Splanker. It's that called. And about the automation, I know of we had a conversation where somebody was using the configuration files, which contain the network details, to automatically create structurizer files. But it was basically like getting the config, parsing it in, then changing it into view and model. Right, so it was quite crude, but mm, because the concern here, I think, is like how can I make them updated? How can I make them not fall behind? But I think it's the sad and intrinsic part that if the time and effort is not given to actually maintain them, they will be outdated, and this is just the way of life, right? Okay. Another part is about the visualizing the data. Um, Unfortunately, this presentation was not about the visualizing data, but about the visualizing processes. However, I think how I would approach that is I would go through documentation of most of the tools that you are attempting to see, because usually you can see like someone is recommending this cool nice graphing library that is working fast, that is doing a lot of things, that makes you feel cool. but it turns out that it will not handle the use cases that you're actually trying to do. I was only using Chart.js, and it was quite good and was enough. But I would stick to the ones that are well documented and well supported, unless you want to do things by hand, right? What is the lesser evil? Choosing the too simple of a tool or too complicated? I err on the side of focusing simplicity first and avoiding complex tools. And like when I was showing you the Excalibur, somebody will always say like, "Whoa, what about a draw IO?" Or "Whoa, you can actually do stuff like that using UML diagrams." Yeah, I can, but before you make a decision on which type of diagram you actually want to use, it's gonna be 5 minutes and you're gonna be tired already, right? With Excalibur, you have nothing to think about. And so my recommendation is to start with Excalibur, start to explain your problem there, and you can end up in the better place. And actually, I have an example of that. So there was in this situation where, let me present my screen again, when I was talking about the payment system, right? So we started, actually, this was the first thing that started it all, right? So the client does initiate payment with card ID to GraphQL, and then we go to Melvis, and then we go to provider, and there's a success or error. And we could see that this was a little bit too complicated to involve other people with, right? So me and the person I was having conversation with knew what's going on here, but the other people would have a difficult time getting into this conversation. So what I decided to do is to translate this, which isn't that nice, into this. This is the same thing, right? It has basically the same details, but it's easier to share and easier to edit and easier to write, right? So what I usually do is I start working on Excalibur, and then if I see like, oh, I need to involve more people, maybe I will go to a mirror, right? Oh, this requires additional details of our architectural stuff. So then I will go to C4, but I always start with Excalibur. Okay, I see that's all the questions, so thanks a lot. If you want to reach out, just find me on LinkedIn. I think it's the one I usually will look up the most. And I hope you enjoyed it. If you have any like comments or you want to strike a conversation, just find me and let's chat. So I hope you enjoyed and have a nice day.